Hi, in this tutorial we're just going to go over atoms, compounds and mixtures. I'm just going to briefly explain what each one is. So atoms, you're probably aware of elements in the periodic table, so things like oxygen, carbon, nitrogen, helium. These will all be familiar to hydrogen. Maybe less familiar is the symbol for gold, things like that. So these are all elements. And what an element is a collection of identical atoms in nature, really. So it's something we can actually grab hold of. So for example, let's have a look at carbon. So carbon in its elemental form can exist as graphite. Okay, graphite's like the lead in your pencil. Also can be diamond, and these are all elemental forms. And now we've got graphene and we've got Buckminster fullerene and things like that. These are all different forms of the same element, so that's an element. Okay, and an element, as you'll find in the periodic table, is a pure form of a collection of atoms. So it's the same atom. So basically, if I drew, say there's a structure of carbon, okay? If I drew the structure of carbon, I could draw it like this as a chemist. Lots of carbons stuck together. Carbon's allowed to have 4 bonds, so it'd be all made up like that, and each carbon there would have 4 bonds, and so on and so on. No other element, no other atom apart from carbon is present in that pure form, and that's what makes an element an element. Okay, so that's where element comes from. Now atom itself, if we look at the hydrogen atom, a hydrogen atom is made up of a proton, and surrounding that proton is an electron, and I'll just draw that electron there in green. Okay, so that is the hydrogen atom, a proton there, an electron there. I'll just draw the proton as a P there. Okay, now that's an atom. Now atoms can react together to form compounds. So a compound is not a pure form of just one atom. Okay, so it's not an element. That's what an element is. A compound, if we look at, let's take carbon and oxygen. So if we look at carbon and oxygen, you might have heard of CO, that's carbon monoxide, or you might have heard of CO2, that's carbon dioxide. So this is a compound. A compound. Okay, and a compound is made up of different atoms. Sometimes we call these compounds molecules, and that's what a molecule is. But a molecule is really just a collection of atoms together that are bonded together covalently or ionically. Okay, and I urge you to have a look at the covalent ionic bonding tutorials to understand what that means. So a molecule really is a compound, and a compound is made up of different elements. So that's got different elements. Okay, but an element on its own is a collection, so different elements, sorry, or different atoms. That's probably best, because elements is a generic term for the pure form of a particular atom. So we've got compounds made up of different types of atoms, and elements are collections of the same atom. An atom itself is an individual form. So for carbon, if I just scroll down a bit, run out of room on there, so carbon would have a mass number of 12, an atomic number of 6, which means it's got 6 protons, and that's what we mean by atoms. It's the individual fundamental building block of matter. It's the uncuttable part Nothing can get smaller than this. In chemistry terms, chemistry doesn't exist once this is cut up, it goes into physics. So 6 protons and 6 neutrons, because that's where the mass number comes from. It's the extra neutrons that don't have charge, and the protons make up the atomic number. That's what really defines what an atom is, the atomic number. That's what defines the difference between so if you look at oxygen, 16 and 8, that's got 8 protons now, and it's got 16 nucleons, and a nucleon is basically a proton or a neutron. So if we take 8 away from 16, we can find out the amount of neutrons. So it's got 8 neutrons as well. So you can see the nucleus, the inside of the atom, is different for the elements, and that is what's changing. That's what makes an atom an atom. It's a change in the nucleus. The electrons should be the same, so I'll put 6 electrons. That's for carbon. However, you can lose the odd electron here and there, but you can't lose protons or neutrons because they're tucked right into the nucleus there. So losing an electron doesn't change the name of the atom. So for example, a good example would be say carbon lost an electron, it would still be carbon. It would just be a charged form. So if it lost 1 electron, it would have a plus charge, because they wouldn't be able to balance out the negative and the positive for the protons and the electrons. Now if we go to compounds, compounds have bonds, whether they're ionic or covalent, as I've written here. So that's a compound is made up like this. One thing I've missed out on this tutorial is mixtures. So I'm just going to get rid of this and just briefly explain mixtures. Now what I'll do, I'll put this to one side because I'll bring that up for the plenary at the end. Actually, I'll just shrink that down a little bit because I can do that with this. Okay. Now mixtures are just basically non-bonded compounds all mixed up together. Now that's not a very good explanation, but if we take air, the air that we breathe, that is made up of oxygen. Oxygen is a compound, an elemental form of oxygen, the atom. It's actually written like that, okay? So it's got a double bond with the oxygens. So that's actually not an atom, it's a compound. It just happens to be a compound made up of the same atom. And that could be regarded as an element of oxygen, the elemental form. Okay, now then, oxygen's in the air, nitrogen's already in the air as well, and there's a little bit of argon, and a little bit of water and things like that. Okay, so I'll stop there really, because these are like the majority of what's in the air at the moment. Now nitrogen is a compound. Argon exists on its own because it's inert gas. Water is a compound. Now water's probably the easiest compound to spot because it's got different elements that make up the compound of water. But together in the atmosphere, in the air that we breathe into our lungs, even when I'm saying this and when you're listening to this tutorial, the air that we're breathing into our lungs is made up of compounds of oxygen, nitrogen, argon, water, and other little bits as well that make up the rest of the atmosphere. But these compounds, these molecules, are not connected together. They're whizzing past each other, mixed up. So it's a bit like getting Lego bricks or something like that, and you've got these represent the red bricks, these represent the green bricks. In fact, let's colour these in. Let's try and show you what I mean. So they're green bricks. These could be red bricks. These can be blue bricks, and we'll leave water as black for now. So if we made lots of these up, which is really when we're breathing things in, it's actually lots and lots and lots and lots of, just get a few of them, for example. I'll just get rid of this as well. Shrink that down, move it out of the way. Move that out of the way. Right, so if we have lots and lots of oxygen, which we're breathing in, you know, if we think of Avogadro's number, there's quite a lot of atoms and compounds that make up a mole of compound. I'll put a few more nitrogens in there. Whoops. Move that across there like that. And that'll do for that one. I'll make a few more of these. Move that there. Move that there. I'll move them all around in a second. And I'll copy that. Move that over here. Move that down here. And I'll move that. I could put that one. Put that there. Okay, so if we look at this now, let's just move these to one side as well. So this is air. This is the air that we breathe. If we could look at it under the most powerful microscope ever built and actually see these atoms floating around, we would see that actually these are whizzing around together, okay, but they're not connected to each other. So if we take the Lego analogy that I just mentioned, where we've got red bricks, green bricks, blue bricks and black bricks all mixed together, then we see that if we accidentally spilt these bricks onto the floor, they'd all mix up together, but they wouldn't actually be connected to each other. So you wouldn't be able to just pick up the red one and then the blue one and the green one and the black one all stuck together. It doesn't work like that. So these compounds are quite happy and stable at room temperature and normal atmospheric conditions to exist on their own as their own molecules. They will whiz past each other, so that nitrogen might be going all the way around, bumping into these molecules, but unfortunately, as it bumps into them, it doesn't necessarily react with them. So this is a mixture of compounds. So that's the difference between a mixture and a compound and an atom, really. So this molecule of water is made up of two atoms, two different types of atoms. One of them is hydrogen, it's got two lots of them, and the other one's oxygen, and that makes it a compound. Argon is just an individual element on its own. As in the atomic form, one atom makes up one argon piece of gas, you know, that's floating around. Oxygen needs to exist as two oxygens bonded together for it to exist in a stable form. Same with nitrogen, but it needs 3 bonds. And these how many bonds are required, you learn as you develop your chemistry knowledge. And if you look at how bonds are made, you'll be able to see why there's 2 there, and why there's 3 there, why there's 1 there, and so on and so on. So hopefully that explains the difference between atoms and compounds and mixtures. I'll just go over what we've covered today. So you remember I mentioned carbon. In the elemental form it exists as graphite and diamond, and that really means as an element this exists made up of just carbon atoms, and an atom is defined by its atomic number and the isotope, which I've not mentioned isotopes because it's not relevant for this tutorial, but you have a look at the isotope tutorial if you want to dig deeper. The isotope of the atom is actually defined by the number of neutrons that are present. Compounds themselves, things like carbon dioxide and carbon monoxide in the atmosphere, these are made up of different atoms, but compounds with elemental forms like oxygen are made up of just one type of atom. Same with nitrogen. but that's still a compound. It's two atoms bound together. So once you've got more than one atom bound, that becomes a compound or a molecule. We call them molecules as well. Mixtures, this is very important because people do get confused with mixtures. Mixtures are made up of different compounds or elements. It could be elemental forms as well. So you could have a mixture. You could have carbon in there as well, or we've got argon there, which is not a compound, it's just an atom. So mixtures are made up of a collection of different atoms or compounds that do not react together. They're just mixed up in a mixture. That's all they are. By definition, they're all just mixed up randomly. And just think of that Lego analogy where you've put all your blue, green, red and black bricks on the floor and they're all mixed up. It's exactly the same thing. So I hope you enjoyed this tutorial. Do look out for the other tutorials on ionic and covalent bonding as well as isotopes, and I'll talk to you soon.